All right. Welcome back, everybody. It feels like it's been quite some time since we've gathered and been through course with the long weekend last weekend and the quiz. So it's been almost 2 weeks since our last time together. And today we have a really exciting topic of variables and while loops. So we're going to start out on paper and pencil and jump straight to, I'll come back to announcements, jump straight to an example. This example makes use of one of the concepts we're learning today, a variable. However, before we introduce variables, I want to give you a chance to try and connect what you already know and have learned this semester with variables and see if you can find some similarities and some correspondences. So there's 2 questions to discuss with a neighbor. And then I'd like you to give a shot at diagramming this. And this will be what gets submitted to Gradescope for today's class attendance. So submit selfie of diagram. So I'm going to turn it over to you all to go ahead and discuss these 2 interesting questions given this code listing, and then work on a diagram. If you'd like to share your hypotheses with a TA, you're more than welcome to. I think you just gotta. 2 more minutes on this, and a reminder to go ahead and submit to Gradescope. 2 more minutes. One more minute to submit. One more minute. Thirty more seconds. 30 more seconds. All right. Let's talk through this. So, I would love to hear from someone who has never, outside of this course, programmed before and is seeing variables in this example for the first time. Tell me, what does line number 2 remind you of that we've seen earlier in this semester? You've seen something like this somewhere else? Anyone want to give an example of where? All right, here we go.
Is it a local value?
It's a local value. That's a correct description of it. And why do you say local?
Because it's only within the function f.
Yeah, so it's defined within the function f. So that's an astute observation. And so you've seen local constants before, and this is a local variable. We'll see that there's some difference. Is there something else that line 2 reminds you of that we've seen before?
Is it the... It's not the keyword argument, but...
It's kind of like a parameter,
Okay.
right? So it's kind of like a parameter. Like in the line above, on line number 1, x is declared as an integer parameter. Here we're declaring y as what was correctly identified as a local variable. And notice that there's a similar declaration. It turns out parameters are a special kind of variable. So you've seen parameters before, you've seen variables before in the form of parameters. But we haven't really used parameters in the way that we're about to start using variables. However, you've seen that same syntax. So we declare y to be a local value within this function definition. And on line 3, this is similar to something else you've seen. Does anyone else want to take a stab at what line 3 reminded you of? Yeah, all right.
It reminds me of a function that you would graph.
A function that you would graph, sure. So we're setting up some expression here where y is assigned x times 2, and this does echo back to mathematics. Is there anywhere else in a program you've written something like this before, like y, then an equal symbol, and then an expression following it?
I'm not quite sure.
Anyone else want to take a stab at that? So it's actually mentioned in the first response, which is kind of like a keyword argument, right? So in a keyword argument, where if we had a function that had, and I should have used, let me actually make this example concrete. With this line 7, we can show, we could have called this function in the way that we began the semester learning how to call functions, where f is called with x is 3, right? But we could have made this if we wanted to. X is, 2 times 2, and had an expression here. We'll notice that there is a correspondence between how we were learning about keyword arguments and what we're going to see is called variable assignment. All right? So great work on that. And then the last thing I want to do is quickly walk through how would we trace this particular example, and then we'll go through announcements and then come back to variables in more depth. So in tracing this, as you know, there's going to be a stack and a heap. And we're going to have globals. And we're going to have a function f that will be id 0. And this is the function. And I'm just going to write dots here. We're hopefully now comfortable enough with how we would declare that that I won't spend extra time on it. We have a function called a f starting on line 7. And we have a parameter, an argument value of 3 being assigned to the parameter x. Right? And so now we reach the important moment where we have a variable declaration statement. And I'm going to use these terms. We'll come back and define these terms more concretely very shortly. But here we're declaring a variable, and its name is y. So I'll choose, let's say, blue as where we go from here. So y is established as a local, and it's a local variable. Right? A key differentiation between variables and constants is naming convention. Right? So one of the ways that you can identify, are we working with a variable versus a constant, is we've got this set up as a lowercase y name, or a lowercase name. And that's pretty true throughout most programming languages that you'll encounter. You tend to use variables with lowercase names. And that completes line 2. So we've declared this variable y, but we have not yet assigned any value to it. On the next line, we see an assignment statement. Right? So you've learned, it's been a while, and we haven't made a whole lot of use of it because we haven't used variables up until now. We've only used parameters and arguments. But this is called the assignment operator. And you're going to hear me say this many times over, and in a reading that you'll see that I emphasize it there as well. You really do not want to interpret this symbol, the single equal symbol, as equality. We're not saying is equal to here. What we're saying is assigned, is associated with, takes the value of, is bound to. Any of these we could use. I'll come back to you in just one moment. And so here, we'll break this down very quickly and then come back to it in more depth. But we have to evaluate the right-hand side first. And we would say x is multiplied by 2. So we look up what is x in our current frame. It's a value of 3. So 3 times 2 is 6. And that value is being assigned to the variable y. And so y's value would now be assigned, or we'll see initialized to be 6. On the very next line, we see return y. So our return value would be whatever y's value is. That's 6. And then we would see that the printed output would just be 6. That's where we're returning this value to. All right. There was a question in the back, and I'll just have you call it out. The ID 0 part. So one of the things that we introduced last week, as we were, or the week before last, and as a quick refresher, is we started the semester with this quick notion that let me choose a different color here. I'll choose purple. That we have arrows going from the stack to the heap, and we still do, right? However, as we started working with more values in the heap, we transitioned to a convention of using IDs. So every object we add to the heap, we're giving those objects an ID. This is true for tuples. This is true for functions. We'll see it's true for more things moving forward. And rather than drawing arrows, because that makes our diagrams pretty messy, we're using IDs to keep track of this, but they are conceptually equivalent. All right, so they're conceptually equivalent. And if you missed the lecture on where we went through this, I would definitely encourage going back and looking through that, as well as the examples that we had for the quiz leading up to it. Other questions on variables? We'll have another example soon. All right, well, great job with this warm-up. Let me jump back to announcements really quickly. So we'll have a reading that is effectively reinforcing what we're doing in class today with a little bit more detail and just a little bit of extra exposure. We'll then, and that'll be due tomorrow night. So this is a quick reading, and there's nothing else due right now. There's no assignments otherwise. And this is just, again, reinforcing what we're doing today. And then we'll have the next exercise out. This will be an implementation of the game Wordle, which is now a New York Times game. When we first started working with this as an assignment, it hadn't been acquired by the New York Times yet. But it does use the concepts of today in LSO7, and this will post by next class, and there will be an announcement on Canvas about this. All right? Great. So I want to introduce the concept of variables to you now that you've seen them. And let's add some notes about variables. Actually, before we do this, I want to give you another, I think it'll be more interesting to go ahead and give you another practice diagram that I think you'll be able to follow through, but this really demonstrates where the use of variables is different from constants, and this will give us some interesting talking points for defining what exactly variables are, how we think of them, and so on. So I want to give you all a chance, let's say about 5 minutes or 4 minutes on this to trace and compare with your neighbors what's going on in this particular diagram. If you have questions, the TAs are circulating around. Happy to help, as am I. I do encourage comparing notes with your neighbors. One more minute on this. One more minute. Twenty more seconds. 20 more seconds. All right, let's talk through this. So in this example, I'm actually going to fast forward from globals and not worry about my globals. But of course, I would not encourage this in general practice. But you all, again, are so comfortable with this. I think it makes sense to just go ahead and say globals. And I'm going to, for demonstration purposes, say this is elided, meaning we're hiding it intentionally. And we get to this call to pizza price on line 11. So our return address is line 11. And there's an argument. Here it's a keyword argument being assigned to our parameter. So size is established and bound to a value of 16. Right? And now that we've established this frame, we are ready to evaluate the function body. So this very first line is actually an example of declaring a local variable and initializing it at the same time. And this is syntax very similar to what you've seen with a constant, where constants you tend to always do this. Because a constant is meant to have one value for the duration of a program and be constant through its use. Here, we have a local variable, and its name is price. So we can go ahead and add that to our current frame. And it's being assigned immediately a value of 10.0. Right? We'll review this terminology, but this is what we call initialization. It's the first time a variable is assigned a value. It's important because you always want to initialize your variables. We'll see why in just a moment. And we're ready to go. On this next line, we see an if statement. And this if statement is testing whether or not the condition size is greater than or equal to 16. So we have to evaluate that Boolean expression. We look in our current frame and ask, do we know if a name size? Yes, we do. That was our parameter 16. And is this true or false? Well, you all know it's true. 16 is equal to 16. So we go into the then body. Right? And here we reach another variable assignment statement. And here's where we have a new concept. Right? So this is the big idea with variables. At this point in time, we're saying price, the variable, is being assigned a value of 20. So how we would indicate this in memory is we would say the value 10 is being replaced with a value 20. Right? And for diagramming purposes, we do encourage crossing out and writing a new value. This helps sort of show a proof of work, so to speak, right? And whether that new value is to the right of it or below it doesn't actually matter. We can intuit that, okay, price is no longer 10, it's now 20, all right? And this is a big idea of variables. We're able to, their values, the values that they are bound to, are able to vary over time. We can reassign the meaning of price, a variable, to be something new as this function body is progressing, right? So just because we said price was initially 10, because it's a variable, we can later change it to be something else. This is different and breaks some intuitions that you all learned in math, right? In math, in algebra, this equal symbol meant something very different. And you have to unlearn or try and forget in this context what you've learned about variables in math. In math, if you said, x is 1 on one line and x is 2 on another line, it would be logically inconsistent, right? That doesn't make sense. But here, we're not saying anything about equality. Variables are exactly names that we give to places and locations where we can store values in memory, right? So price is this location where we can store some float value, and now it's being bound to 20. And finally, when we reach line 8, we return price. So my return value of this function would be, of course, what is the current value of price, 20. And that would be what is printed here. Any questions on this example? Yep, go ahead. Yeah. So the question is, and in fact, the next example does iterate on this, and we will have a value that's less than 16. But the question, which is an astute question, this doesn't actually resolve the main point of the next example. But the question is, what if we had tried this with, instead of size 16, we tried it with size 15, say? Well, we would have come in and for purposes of this example, I'm going to switch to my color, switch to the color purple. So size would have been 15. Let me try that again. That's pretty small. Size would have been 15. We come in, and price would have initialized to be 10, just as we did here. We reach this is size greater than or equal to 16, and I should have deleted this, my bad. No, because size is currently 15. So we skip over the then block, and then we just return price. And yes, the intuition that was asked in the question was exactly correct. The return value would just be whatever the current value of price is. All right, so we're having to look up its value every time we access that variable or use that variable after it's been declared. Great question. And then, of course, that would have ultimately resolved in an output of 10.0. Questions? Other questions on this? Yeah, go ahead and call it out. Great question. The question is it possible to have multiple variable reassignments in the same function, and would you just keep crossing them out? I want to give you all a chance to try. The intuition is yes, it is possible, so I'll give that away here. But rather than trying to explain it, because we have an example that is an iteration on what we just did, I want to go ahead and give you one more possible example here to work through. This is different. There are more lines of code here. And I want you to try diagramming this with your neighbors as well. And we'll come back in 5 minutes. And I'm going to apologize that because we have skipped around and been following the order of questions here, we won't necessarily be able to identify these things yet. So you can skip that, and we'll come back to that. I do encourage trying to diagram this. It's good practice. Two more minutes on this one. 2 more minutes. Compare with your neighbors. Did you get the same price calculation of what this pizza should cost? One more minute. One more minute. All right. Let's bring it back together. And again, I've gone ahead and fast forwarded through what should be very comfortable at this point in the semester. So we've got our frame set up for pizza price. We've got our size and toppings parameters filled in with the arguments we were given. And now we reach line 3. And I want to begin using this terminology we're about to define more concretely. But here we reach a variable declaration. If we wanted to be even more precise, this is a local variable declaration, as was initially identified from the audience. And this is also a variable assignment statement. And it's a special kind of variable assignment statement. It's the first time we're assigning to a variable. Therefore, it's the initialization of a variable. What this has the effect of doing, I'll write in purple, it sets up a variable named price and initializes it or binds it a value of 10, right? We then reach this if statement, and we've actually talked through this before because there's the astute question from the audience. What happens if this is not true? Well, if this is not true, then we do not go into the body. And because size in this example, in this frame, is currently 14, if I could switch to my eraser, we do not assign price to be 20 because 14 is not greater than or equal to 16. That was false, so we skip over that line. And then we reach another variable assignment statement. And here you're seeing another example of something that in math is completely illogical, right? So you cannot use your intuitions from math and algebra to make sense of this because there's no way for price to be equal to price plus topping. That doesn't make sense, right? It's illogical. And that's okay because this has nothing to do with equality. This has everything to do with variable assignment. So this is a variable assignment statement. And what we'll learn is we always have to focus on the right-hand side first. Another piece of intuition that fails you for math is these sides cannot be flipped, right? We couldn't reverse price plus toppings times 0.75 is equal to price. That doesn't work. The variable name that we're assigning to is on the left-hand side of this assignment operator, and then the expression that we want to bind to that variable is on the right-hand side. So we first have to evaluate this. And here we look up, do we know what price is? Price is currently 10.0. And we look up what is toppings. So toppings is 2 multiplied by 0.75. So 10.0 plus 1.5 is 11.5, right? Now that we've evaluated this expression, we bind that value to the price variable. So we no longer have a price of 10. That price is being updated to be 11.5 or 11.50. Python would technically treat this as 11.5, but if you wrote 11.50, that's fine. And finally, we go and we reach this return statement. We return the current value of price, and that would be 11.5, right? And the output would be 11.5. Questions on this example? Yeah. Assignment or reassignment? Yeah. Great question. So the question is, do you always read it from right to left? And what I want to point out here is there are two distinct pieces of assignment, or there's three actually. This is our assignment operator, and we're going to learn that we treat everything to the left of this specially, mainly that we're only looking for a variable name there. And then everything to the right of this, we treat as a single expression. Here, I could have evaluated this multiplication first, and in some ways I did. But the substitution of how you work through that, it doesn't actually matter. It would be important, though, that you followed the order of operations and were sure to perform this multiplication before the addition. And that is important. So you would not have wanted to do price plus toppings and then multiplied that by 0.75. That would not have given you the correct answer. Yep. So just treat that as a normal expression. Yep, question. Why is there not an else statement? Good question. This is a fantastic question. Another way of writing this, this is actually such an instructional question, and I love it. I want to take the time to properly address it. So we could have also written this as price, as a float, and this is a variable declaration. And we could have said something like, if size is greater than or equal to 16, then price is 20. Else, price is assigned 10.0. And these two programs would have been exactly the same in their implementation and outcomes, right? We say we're declaring a variable named price, but we're not initializing it to any value. And then if it's greater than or equal to 16, it will be 20. If it's not, it will be 10. And we could have written that in a different way, right? We could have said if size is less than 16, it's 10. If it's else, it's 20. A common trick that I perhaps shouldn't have relied upon here, but a common simplification is, well, if you think of what is the default value that you might assume price is, so we start out price at 10, and then only in the special case where the size of our pizza is greater than 16 inches, that's when we want to upgrade the price to be 20. We're able to achieve the same thing, and the logic works out the same. So the reason why we didn't include the else here was because we already had a baseline value of price that was 10.0. Does that help? And so the else branch is optional. It's the equivalent of saying else and then doing nothing, 3 dots here. So either of these would have resulted in the same program. Other questions? I heard some murmuring from the back and saw some pointing in this side of the room. So I just want to give an opportunity. If there's something on this slide that feels uncomfortable, don't be afraid to ask. Because there is something very uncomfortable about seeing a statement like line 8, right? That it breaks your mind a little bit when you've been trained for so many years algebraically and thinking this is some equation. This is not an equation. It's a variable assignment statement. Yeah, one more. Yep. Great question. Oh my gosh. I love these questions. And you all are, I promise you we're going to get to defining terms first, but because the questions are leading us down such a fantastic road, I want to give you the opportunity to think through this. You don't have to actually trace it, but think through this, because this is exactly the question that came from the audience, which is, if we didn't assign anything to price here, do we have a problem? And I want to give you all just a moment to think about whether yes or no there might be a problem with this. And if you wanted to try tracing this just briefly, you could. 30 more seconds on this. 30 more seconds. Show of hands. How many of you think there's a problem here? Yeah, there is a problem here. So as was correctly identified, if we imagine how this would work out, right? Right, I don't have, so I'm just going to have pizza price, and my RA is 13, my size is 14, my toppings 2. That's all fun and good, and then we reach this line 3. This is a variable declaration, but notice we're not initializing it. So all we do here is say, okay, there's a variable named price, no value assigned to it, all right? We reach this if statement, and this if statement says if size is greater than or equal to 16, that's false. Nothing going there, so we don't have to do anything with that next statement on line 6. And then we reach this line, this variable assignment line. And once again, we always want to focus on simplifying this expression on the right-hand side of the assignment operator first. That's our first goal. And as we're doing this, as we're substituting these names and values, one of the first things we do is we look up, hey, what is the current value of price? And see, uh-oh, there is no current value of price. At this point in your program, Python would crash, and you would see that there's an unbound local error in this case, because we had previously declared a variable named price, but we never assigned a value to it. So it's an unbound local. It would tell you that price has not been associated with a value yet, and you tried to access it or read it, and that's a problem because there's nothing there. We don't know what this value should be. That's some kind of logical error in your program. So to answer the question, if we didn't initialize it, yes, you'd need to have an else statement, and be sure that before you go and access a variable, you always want to be sure it's initialized. That's a hard rule of thumb in every programming language, and important to remember. Before you access or use a variable, you need to have assigned to it first at some point in your program. Questions on this example? All right, I'm loving the path that we're taking through questions getting to where I was hoping we would go. But we've skipped over some things, and we need to return back and define some terminology. So let's just get some key terminology down and then practice identifying this in the code listings we've looked at, in one of the code listings we've looked at. Variable declaration associates a name, which is an identifier, with space in the current frame context, and a data type. So just like parameters, when we declare a variable, we're saying we're setting this name is going to refer to something of type int or string or bool or tuple or other types that we'll explore, and some types that we'll even be able to invent on our own, right? And this gives us a sense that, okay, whenever we use this name later, this is what we're referring to. We're referring to some value in memory that has some specific type associated with it, all right? Now, as we just learned, there's a key difference between declaring a variable and assigning a value to a variable. So a variable assignment is, I'm going to try and make a line here, binds a new value to a variable name in memory. And binds could be thought of as assignment, but because it's called assignment, I'm just going to leave it as such. You could also think of this as associates. It's effectively saying, hey, whenever you refer to this variable name from here on out or from this point forward, this is going to be its new value, right? Variable initialization is a special name we give to the first time a variable is assigned. And what we just learned is, getting a little bit ahead of ourselves, was that this is given a special name and rises to a level of importance because if we fail to initialize a variable accidentally, it will probably lead to errors in our program later on. So one of the sanity checks as you're writing programs and being sure that you're doing things in an expected way is to be sure you're initializing your variables as soon as you know what they should be initialized to. Most of the time, you're going to see that you can do declaration and initialization at the exact point in time. But there are cases where you have to declare first, and then it won't be until later in the program that you know that what that variable should be initialized to. But it is important to be sure that you always initialize and are confident you've initialized before you access. And the last term here, access, is reading, I'm going to put this in quotes, or using a variable name in an expression. And why this is important is whenever we access, when we get to this point as we're tracing through the program or Python's trying to evaluate an expression for us, when we reach a variable access, this is when name resolutions apply. So when evaluated, name resolution rules determine the value substituted. And so far, we've been looking at local variables. So we look in our current frame and see, do we know what this variable is bound to? We'll look at global variables later, but I just want to go ahead and plant firmly that global variables tend to create so many problems in programs and are so hard to think about and reason about and create subtle bugs that we tend to try and go to extreme lengths to avoid the use of global variables. Global constants, on the other hand, are perfectly fine. But global variables make our programs much harder to reason about. So when in doubt, always try and use local variables defined within the context of a function body. Okay? Any questions on this terminology? Yep.
What's the difference between a global variable and a global constant?
The difference between a global variable and a global constant is that you could imagine changing a global variable as your program runs. So a constant is supposed to be one value for the entirety of your program. So it's like pi. You're probably never going to change what the value pi, right? It's always 3.14 and as many digits as you want to go. You could imagine writing a program like a game where player 1 points were some global variable, and you updated that from many different functions. Well, the challenge with global variables is it's hard to keep track of where are these changes coming from. And when you start to find yourself in a place of having a hard time figuring out how did you get to this point in a program, your programs become harder to debug. So we'll see more examples of this as we get further in, but when in doubt, use local variables rather than global variables. And it turns out Python, in fact, goes out of its way to prevent you from changing global variables with some rules we'll see later, just so that you know how to do it if you ever needed to. But again, it's something we try to avoid generally. All right. So there are two errors that are very common. The first one we've already looked at, an unbound local. The second one, which you'll also read about, so I'm not going to go into too much depth here, but is a name error. And if we had some function, so if I had some function like def f, let's just say it's a very simple function with no parameters, returns none. And I had said something like print. Let me give you an actual common example of this. So we have a variable like jump is a int, and it's assigned 10. And then I tried to print, and I printed jump with a capital J. We would see a name error, because when we use our name resolution rules and we try and see what is jump with a capital J, well, no one's ever defined anything named jump with a capital J. It looks like this name has never been defined. So this is different from a name that has been declared or defined but not yet initialized. And say, I don't know what this name is that you're referring to. I'm going to throw up my hands. There is a chance that if what you did was like a subtle typo, like in this case, I think Python would say, did you mean jump with a lowercase? And it tries to be helpful. All right? This is in the reading, so we'll have time to look at that as well. So I want to give one motivation for why variables and then look at another even more compelling one soon. Imagine we were building a simple little Mad Libs game here, or a Mad Libs function, and we wanted to ask the user for multiple pieces of input. A common use of variables would be to store the input that a user gave in a local variable and then refer to it later. If we had had variables when you implemented the Tea Party program, you would have been able to do things more like this to clean up that main function, store some of the calculation results that you needed to use at different times, and not have to repeat calculations as well. So it gives you a chance to say if there's some piece of input that you wanted to use in multiple different places in your program, gives you one way of doing that, and it's some storage space for values. All right? More compelling reasons are also given in the reading tonight, and then we're about to see one very soon, which is going into the next example. So everyone's got their pencil and paper out. We're going to have a quick competition to see who can write the numbers 1 through 1,000 the fastest. All right, 3, 2, 1, go. All right, I'm seeing some people actually doing this. This is not actually a real competition. I hope that you are probably thinking like, man, what is he? What kind of a joker does he think he is for making us do something like this? And what I want to impress upon you is that as humans, some of this very tedious work, I think this would have maybe been, if I had said this or this, it would have been even more apparent. But some of these activities that feel very tedious to humans are fundamentally what our computers are very good at, very happy to do on our behalf. If they had emotion, I think they would be happy. I hope they would be. And so let's take a look at how we might do this. And I actually want to do this in code with you all together. So we're going to introduce a concept called a while loop. And I'm going to switch over to my laptop to do this. And I'll have you all join me in VS Code as well. All right. So I'll have you, actually let me rename this. I want to use a convention of lowercase for these names. If you'll set up a program named You Are Loved, and define a function named love that takes a parameter n and currently does nothing. I'll give you all a moment to catch up here. And if for some reason VS Code is giving you issues or something like that, if you want to just jot down these as notes, that's totally fine too. Don't stress if something's technically not working for you. You're not handing this in. We're just doing this as an example together. So one of the first things that one of the other superpowers of a variable, this notion that we can have a value that changes in a place in memory over time, is we can set up something like a counter. So I'm going to set up a variable that's counter and go ahead and initialize it to 0. All right. VS Code will occasionally give you squiggly lines like you're seeing here. And if you hover over something that has squiggly lines, it'll say that this is not accessed. So we've already learned this terminology. This means that counter is not read anywhere else. And typically, if you declare a local variable and never read it, that's some symbol that you probably can get rid of that local variable. But in this case, it's kind of unhelpful because we're trying to write a program, and of course we haven't made use of it yet. We're still writing it. And I want to point out that this is OK. Don't feel like you have to address squiggly codes, especially the yellow ones. Red ones are a little more concerning, and you should look at what's going on there. But yellow ones are kind of like hints that, hey, you might have something you want to double check here and be sure that you intended to do. And in this case, we did intend to have this variable set up. We're setting up a local variable named counter. It starts at 0. And what we're about to see is a new type of statement called a while statement. So I'm going to declare the while keyword. And while is a statement that works very similar to if. It's closely related. It's a control flow statement. And so just like if, we're going to have a Boolean expression that follows the while statement. That's some test that we want to perform. So my test is going to be while counter is less than n. Right? And the next thing that I want to encourage you to do right now before anyone accidentally goes and tries and runs this program, although it has an error in it, is let's go ahead and increment our counter. So counter is counter plus 1. Okay? And notice that just like an if statement, our body of a while loop is indented by 1 level. And here we're seeing it again, one of those funny-looking variable assignment statements. And I would encourage you to read this as the counter variable is assigned the current value of the counter variable plus 1. Or more succinctly, as you become comfortable with this being a very common line of code that you'll see in other scenarios as well, is we're incrementing counter by 1. After this line evaluates, counter's value will be 1 more than it was before this line had evaluated. All right? And let's put in a print statement. So let's say, just for demonstration purposes, I'm going to print counter here. So we can try running this really quickly. And we can say, love. And then I can say n is 3, right? And we see 0, 1, 2. Well, this is fascinating. This means that there must be something more going on in this example than with an if statement. Because in an if statement, we would have said, if counter is less than n, print the counter, increment counter by 1, and then we're done, right? So the key difference between a while loop and an if statement is at the end of the while loop's body, so after counter is assigned counter plus 1, execution jumps back up to that test. It loops back to line 4 and tests again, is this true or false? And if it's true, counter is still less than n, we go back into the loop, we print counter again, we increment counter by 1, and once again, we go back to the top and we test. So now n would be 1, or counter would be 2, counter less than n, which was 3 in this case, is true. So we go in, we print 2. Counter is assigned counter plus 1, so counter would be 3. We go back up, we test again, is 3 less than 3, that's false. And then our program would be done. This is one of those functions that doesn't return anything. If we wanted to convince ourselves that counter after this was done, we could do a print statement here, like print f string final counter. And I'll just make this counter. Counter. All right. And so I could use my REPL to try love, and I'll do an n of 3 again. This time I'll just use a value, or just a positional parameter, positional argument, I should say. And there we go. We see that 0, 1, 2 are printed, and then finally 3. Before we expand on this example a little bit, questions about what we're seeing here? Yep, go ahead. Great question. If you didn't want to start at 0 and you wanted to start at 1, there are 2 great options. So one is we could just initialize to 1. And if we did that, we would see what you would hopefully expect. So love 3 again, 1, 2. Then our final value was 3. But if you wanted this to print 3 times, 1, 2, 3, we have some options there too. So we know that this is an expression, and expressions are where we can have a little bit more control. So I could have said less than or equal to n here. So less than or equal to 3, that would have still been true. We can save this, try running it again, love 3. And we get 1, 2, 3, and then that final value is 4, and we're done. All right? I want to revert my example back to starting from 0 and show you one other way. If you really wanted that output, oops, let me go back to here, counter, counter. We could have also printed counter plus 1 as an expression here, or set up another variable, and this would have had a similar output. But notice that our counter, because we were just making an expression and printing it there, it's still 3. I'm going to leave this as initially was. And the reason why we tend to start these kinds of loops from 0 and use less than as our bounds actually relates back to something like a tuple, where you have an index. That index always starts from 0 and goes up to 1 less than the length of the tuple. Right? Other questions on what we're seeing here? So one of the things that I want to impress upon you is, and I want to be sure that you all have this program here in case you're ever frustrated with the way things are going in this course. And let's change this slightly, and let's print an F string. That is, I love you, and then put in your first name. So I'll do Chris, and then counter. All right? So now we've got a slightly different program here. If I did love 3, we can see that, of course, my computer is giving me some love. But the example that I want to give you is, well, I don't know. Think about how old you are, how many years old you are. I'll give this away while I still can. My birthday is coming up. I'm 38. And there's 365 days in a year. And I'm going to hypothesize that this is about how many times, let's say on average, I'm told I'm loved 1.5 times a day. So 20,800 times. So I'm going to try rerunning my program here 21,000 times. And pretty soon, although it does slow down, I'll give you a caveat here that as we get higher and higher, our computer is working a little bit harder with what it's doing behind the scenes, mostly on the Trailhead side. But within a reasonable amount of time, and if you try this on yours, my program here has told me it loves me more than I've been told for my entire life. And so if you're ever feeling lonely, or frustrated, know that you've just written a program that will tell you it loves you. And if you want, I could expand this, right? And it's telling you it loves you more than you've been told in your entire life by your parents, your friends, your family. And if you don't need a better reason to study computer science, know that it's reinforcing of love, all right? But my point here is this. I asked you all to write as fast as you could from 0 to 100, I think, or 1,000 maybe, some numbers down. And if you tried to do it, it would have been painful and tedious. And you really didn't want to do it. Well, here, it's so simple and so powerful to be able to write programs that will loop. Again, in this case, that ran. And it was actually, if we wanted to do this in a different way, it's much faster than what you're seeing here. Our computers are running billions of operations per second, and something like this is actually much faster. What took most of the time was getting it to show up on the screen this many times. But yeah, so if I scroll down, it did successfully get me there. All right. I'm going to switch back over to my laptop really quickly and give you all one final tracing, or sorry, my iPad really quickly, and give you all one final tracing example to try and work through. All right, so this will be the final example of the day. Try working through this. "30 more seconds, and we'll talk through this. I don't expect that you fully completed this, so don't stress if you're in the middle of it, but I do want to have time to talk through it. All right. So for the purposes of time, I want to explain what's going on here. And because we haven't actually traced through an example with a while loop yet using a diagram, there's a key step that we just need to remember. So here we reach I've fast forwarded. I've gone ahead and set up my local variables in purple, total and I, just to make them stand out a little bit. And we reach this while statement. We have a Boolean expression, I less than the length of x's. So x's is ID 1. We look up what is the length of our tuple. Our tuple has 3 elements in it. And we know that we can't change tuples, so length is always going to be, of a tuple is always going to be the same. So this is going to be 3. And here we look up is I, which is 0, less than 3. That's true. So we step in, and we reach this variable assignment statement. We look up what is total. So total's value is 0. We look up what is x's index I. So again, x is the ID of 1 on the heap. Index I is 0 currently. So we look at what is the value for index 0 of this tuple. That's the value 1. 0 plus 1 is 1. And we're ready to assign a new value to total. Right? So we've taken the right-hand side, and we're reassigning total on the left-hand side. So total is going to be updated. Its value is now going to be 1. Right? And 1. Great. So then we reach the next variable assignment statement. This one's a little simpler. We take the current value of I. That is 0. 0 plus 1 is 1. And now we're going to assign 1 to I. So I's value is going to be updated. And I's new value will be 1. All right. And here's the important piece. The key difference between a while statement and an if statement is the while statement is a loop. So we go from here back to the top. So we loop back around, and we have to test this condition one more time and do the same set of steps again. So it's like we've just gone back to line 5 and do it all over again, start afresh. But notice that the state in our stack frame has changed, so this might not be the same outcome. And so I is less than length of x's. That's still 3. That's still true. We update total. So total is currently 1 plus x's index of 1 because I is now 1. So that's this value here. That's going to be 2, right? So we're looking at the next item in our tuple. 1 plus 2, of course, is 3. 3 gets reassigned back to total. So total's value is now 3. Right? So we're summing up the items in our tuple. But we're not done yet. So we have I plus 1. I is currently 1. 1 plus 1 is 2. So now I's new value is going to be 2. We've reached the end of our while loop. So we once again have to go back up and test. Is I, which is now 2, less than 3? That's true. So we still have a little bit more work to do. Once again, we reach this assignment statement. So we take total. Current value is 3. 3 plus x's of index I. Again, x is index I. I is currently 2. So x is of index 2 has a value of 3. So this is 3 plus 3. And that's, of course, 6. And that causes us to update our total to be 6. We then increment I to be 1 more than it currently is. Hopefully you're getting used to this type of statement, simply just replacing a value and adding 1 to it. But we're not done yet. So now we go in and we test again. Is 3 less than the length of x's? Is 3 less than 3? That's now false. As soon as this condition becomes false, we jump over the while loop body. And here we reach a return statement, and we return total. So the return value here would be 6. And that would be what's printed out. So we've seen this same algorithm implemented recursively, as we're seeing here implemented iteratively using loops. The next reading is on variables and while loops, and we'll be out and due tomorrow. Great work today. You are loved.